This is the fourth game from the Juno 7 LSAT. Here are the scenario and the rules. Please go ahead and pause this video if you'd like a chance to try and set it up on your own before we move forward. For this game, we have 5 elements, G, N, P, T, and W, being placed into 3 groups, centers 1, 2, and 3. Each group will have at least 2 and at most 3 elements. We can represent all that information like this, using boxes for the 2 spaces in each group that we know must be filled, and leaving a line for the 3rd space in each group, which may or may not be filled. We are given just 3 rules for this game, but each of them requires some careful consideration, and ultimately they do reveal a whole lot about the situation we're given. When we think about how rules 2 and 3 go together, they present very limited options for where we can place P. If we can only have one P, and every element in group 2 has to go into group 1, though not necessarily vice versa, P can't go in group 2. That means P can only go in groups 1 or 3, and we can set up 2 frames to represent these 2 scenarios. In either case, when we place P into one group, we know it can't go into any of the other groups, and we can go ahead and cross it out from underneath them. The third rule also tells us that P can't be with G. For the first frame, that means G can't be in group 1, and it also means G can't be in group 2, because that would force it into 1. Since we have to have at least one G in there somewhere, that means that for this frame, we have to put a G in group 3. For the second frame, we know G can't be in group 3. That means it could be in just group 1, or again, because everything in 2 has to be in 1, it could be in both groups 1 and 2. In either case, there must be a G in 1, and so we can write that inference in. Now we can consider the second rule more carefully, notate it, and make inferences. For the first frame, since group 2 can't have P, and every element in group 2 must be in group 1, we know that group 2 can only have 2 elements, and we can cross out the top position for group 2. And we also know that both of those elements in group 2 must also be in group 1. We can represent this last bit of information with both an arrow indicating that everything in 2 must go in 1, and an equal sign that tells us that these positions must be filled by the same exact element. And we have to move the P to make it clear that the P isn't one of those items that are repeated in both groups 1 and 2. For the second frame, there weren't the same sorts of numerical inferences to be made, and so I just made sure to clearly notate the rule with an arrow connecting elements from group 2 to group 1. Now we need to return to the first rule, which tells us that any W must be accompanied by an N. Note that this doesn't mean that W and N must always go together. Notice that we could have an N without a W, and that wouldn't violate this condition. What it does tell us is that when we do have W in any group, we must also have an N. And so we can represent that with a conditional. We can also make a small inference in the first frame based off this rule. If you look at just group 2, and you certainly don't have to think about it this way, but this is how it came to me, we have 3 elements, N, T, and W, that can fill 2 positions. And per this first rule, there are only 2 possible ways to actually fill these positions. Please pause the video if you want to try to figure it out on your own first. We can either fill these 2 slots with W and N, or T and N. But that's it. Because of this first rule, we can't fill it with W and T. So, we know that for this frame, group 2 will either be WN or TN. No matter the combination, group 2 will have to have an N, and it'll also have to have a T or a W as well. Again, this is a very subtle inference, but it turns out to be a significant one. When we get to the questions, over and over again, we're going to have to think about how those three elements, N, T, and W, can fit into two positions. So, I hope those inferences made sense to you, but if they didn't, please review this part of the video again before moving forward. Once we know what goes into the second group, we can match that in the first group. And lastly, because T is the one element that hasn't been mentioned in the rules, you may want to mark it so we know that it's a free agent that can essentially go anywhere. So here's our completed diagram. More so than any of the other three games in this series of videos, this diagram is the most technical, and it's also the most LSAT trainer specific. You certainly didn't have to set it up this way, and you certainly could have had success setting this game up many other ways. But if this works for you, I think you'll see that this diagram will be extremely useful to us as we go into the questions. If you're unfamiliar with trainer strategies, or especially if you're new to LSAT prep, I realize this may seem a bit overwhelming, so please don't hesitate to rewatch the setup part of this video if you'd like before we move forward. With all that said, let's go ahead and move on to the questions. Here's problem number 18. This is a rules question, or a question that asks for one possible arrangement of elements into positions per the rules that were given. We can solve this problem by going down the list of rules and eliminating the answer choices that violate them. The first rule, which tells us we can't have a W without an N, allows us to eliminate answer choice A, which has W without N in center 3. The second rule, which tells us that every element in 2 must be in 1, allows us to eliminate answer choice C, which has tin in center 2, but not center 1. And the third rule, which tells us that we have to have exactly one P, and that the one P can't be with G, allows us to eliminate answer choices D and E. D has P with G, and E has 2 P's. So, we've been able to eliminate 4 answers that violate the given rules, and the one remaining answer, B, is the correct one. Here's problem number 19. We set up our frames around the inference that P can be in 1 and 3 and not 2, and we know that both these frames are completely viable. And so the correct answer is answer choice D. Here's question 20. If center 2 recycles 3 types of material, we know we're dealing with the second frame, and in the second frame, we know P must go in center 3. So, the correct answer is answer choice C. Here's question 21. If each center recycles 3 items, we know we have to be in the second frame. And like some of our previous work, the key inferences come in large part from knowing that we have a limited number of elements we can choose from in order to fill our positions. First, we know that if all 3 groups are filled for group 2, since every element in group 2 must also be in group 1, for this situation we know G must be in group 2. That leaves N, T, and W for the remaining 2 spots in group 2. And of course group 1 as well. Per the conditional rule, we know we can't have a W without an N, so in terms of filling in the positions, we can either do so with NT or NW. We can represent those options essentially as we did earlier, with an N in one spot and a T/W in the other. For group 3, we again have these same three elements, N, T, and W, for two positions, and we can make the same inference that N must be in group 3, with either T or W. Per our inferences, answer choices A, B, C, and E all must be false. And if you want to pause the video to verify that, you can certainly do so. And D is the only answer that could be true, and so D is correct. Here's question 22. If center 3 recycles G, we know we're dealing with the first frame, and in the first frame, we know center 2 must recycle N. So, the correct answer is answer choice B. Here's our final problem, question 23. If W is only in 1, we know we're dealing with the second frame, because in the first frame, for W to be in 1, it'd also have to be in 2. So let's go ahead and place W into 1 in the second frame and make some inferences. First, since 2 can't have W and everything in 2 must be in 1, we know 2 can have at most 2 elements, and we can cross out the third position for group 2. You can also cross out W from under groups 2 and 3 if you'd like. We also know that groups 1 and 2 must share 2 elements in common. We know in this frame group 1 has a G, and we also know per the conditional rule that since group 1 has a W, it must have an N. This tells us that group 2 must also have G and N. Moving on to group 3, we know that it can't have G and it can't have W. So there are 2 remaining elements that could go into group 3, either N or T. So group 3 can, along with P, have either N, T, or both. Now let's take a look at the answer choices. A seems like it's possible in the third group, so let's go ahead and leave it. B isn't possible in any group, so we can eliminate it. C isn't possible in any of our groups, so we can eliminate it. D isn't possible in any of our groups, so we can eliminate it. And finally, E also isn't possible in any of our groups, so we can eliminate that as well. Going back to A, again, there's no reason why group 3 can't recycle just plastic and tin, and so A is the correct answer. That's it. Thanks so much for watching. Again, my name is Mike Kim, and I'm the author of the LSAT Trainer. For more LSAT prep help, please check out my other videos, the LSAT Trainer website, and of course, the LSAT Trainer study guide. I hope you found that helpful. Take care, and I wish you all the best on test day.